Hello everyone, welcome to my channel Mac Pandit's Learning Hub. So as you are already aware that in this session we are going to talk about the velocity analysis and mechanisms using graphical vector approach. So if you remember, in the previous session we discussed about how can we represent a vector and basically how can we use triangle law for addition or subtraction of vectors. Now in this session we will start with a basic analysis, that is particularly the velocity analysis of a link. So before jumping directly to a mechanism which is nothing, a combination of links, we will simply see how to first conduct the velocity analysis of a link. Now if you observe this diagram carefully, so in this diagram let us first see what is provided to us. So you can see here there is a link OA. Now this link OA, it is having a length of R. Now this link OA, it is rotating at an angular speed of omega. So usually if you observe that before conducting the velocity analysis, generally some certain data is already provided to us or it is available with us. So in this case you can see the length of link OA that will be available with us, as well as at the same time the angular speed of link OA that is also given to us, right? So you can see here this link OA, it is rotating in a anti-clockwise direction. Now let us see what is our objective here. So this is the data which is provided to us. Now our objective here is to find out the linear velocity of point A with respect to O, right? So we can simply say our objective here is to find out VAO, that is relative velocity of point A with respect to O. Now let us see how can we do that. So obviously we have to establish a relationship between VAO, small r and omega. So let's move to the next diagram and let's say how can we actually figure out the relation between these three parameters. So in this diagram you can see here, initially we will assume that the link OA, it is in vertical position, correct? So let me just write down here, initially, or you can simply say at time t the link OA is in vertical position. Now we will assume that after time delta t, the link OA, it rotates through an angle of delta theta and it acquires a new position which is OA prime. So we can simply say at time t plus delta t, right, link OA rotates through angle delta theta and acquires new position OA prime. Now to simply find out the linear velocity of point A with respect to O, we can use this relation which is given by VAO vector is simply equal to distance traveled. So here the distance traveled by point A in time delta t, it is simply given by the length of this arc AA prime. So arc AA prime divided by the time taken, which is delta t. Now from the relation angle equal to arc upon radius, we can simply say that the length AA prime, it will be given by r delta theta. So we can see here that this thing is applicable for infinitesimally small amount of time delta t. So here we can substitute arc AA prime equal to r delta theta divided by delta t. Now when this limit delta t tends to 0, so after taking the limits, this entire equation, it will reduce to simply VAO equal to r d theta by dt, and we know that this rate of change of angle with respect to time, it is nothing, it is simply angular velocity omega. So you can see here that the linear velocity of point A with respect to O is simply equal to r omega. Now let us see further that how can we actually represent this VAO vector. So as we know that VAO vector in the vector diagram, it will be simply given by which vector? The vector OA, right? So as you can see here, when we are going to represent this VAO vector, the direction of this vector becomes very important. So let us see how to figure out the direction of this vector. So obviously the direction of this vector, if you can see from this diagram, since this link OA, it is rotating in anti-clockwise direction, so this point A, it will tend to move towards the left side. So obviously VAO vector, it will be perpendicular to this length OA, and at the same time the direction of OA vector or VAO vector, it will be towards left. So you can see here in this diagram, we have simply represented this VAO vector, or you can say OA vector. So we will start with small o, and then we are going to end the vector with small a. So O basically represents the tail of vector and small a represents the head of this vector. So you can see here this OA vector, it will be pointing towards the left direction, and obviously this OA vector, it will be perpendicular to the length capital OA. Just remember this point. So we can also call this velocity as tangential velocity of point A with respect to O. Now let's move ahead and let's see if somewhere we take a point B on this link. So let's say I am giving you the length OB, right? So length OB, this is given to you, right? And somewhere on this link OA, we are going to mark this point OB, right? Now let's see here how to calculate the velocity of this point B. So one simple approach is, let's say if we take the length of OB as R1, so this will simply become V equal to R1 omega. But in case we want to leverage this vector diagram to calculate the velocity of B with respect to O, so how can we do that? So let us see that. So in that case, we will simply say that OB is the velocity of point B, and now this point small b, it will divide the vector OA exactly in the same ratio as the point capital B is dividing the length capital OA. So just remember this point. So you can simply say that OB upon OA, this will be nothing, this will be simply equal to capital OB divided by capital OA, right? So just I am going to repeat this thing again. So let me briefly write it down here so that it becomes clear. So to calculate OB, just remember this law that mark B on OA vector such that B divides OA in the same ratio as capital B divides the length OA. So just remember this point. This point becomes very important because this will be used in further analysis of mechanisms, right? So we can simply say that OB upon OA is equal to capital OB divided by capital OA. From here you can calculate the length OB, which is simply OB divided by OA multiplied by small oa, and then once you calculate this length OB, you can mark this point B on the vector OA, right? So with this, I would like to conclude this session for the velocity analysis of a link. Hope to see you in the. Thank you.